My name's Miguel, also known as the Vegan Math Guy, and you're at Lake Algebra 2 at Sokotoa Park. Let's go explore the conics of circles. Before we start this video, I just want to mention to please subscribe to my YouTube channel. Please follow me on Instagram and TikTok, where I post a lot of math content for you to enjoy. And if you have any questions, feel free to email me or DM me or even drop a comment in this particular video. All right, so let's go ahead and get started and talk about circles. The very first thing that we need to know whenever we are doing circles is the equation of the circle. And this is the equation for a conic. By this point, I'm sure you've already have seen this equation, but let's go ahead and talk about why it's important to know it, what the H, what the K, and what the R represents. So whenever you have a circle, especially for a graph, we're going to be given the center, and that's going to be H comma K. So whatever that value is, that's going to tell us where the center of the circle is. Now, pay particular attention to those minus signs inside the standard form for a conic. And I know a lot of people get really confused when you see that minus sign, a lot of people think that your function is going to be moving however many units to the left. But every time you have that minus sign, it's actually going to be moving to the right. So I think it's just particularly important to remember that it's always the opposite value whenever it comes to transformations. Okay, so our center is H comma K, and of course our R is going to be the radius of this conic. And we're going to use that in a second to graph a particular conic. So I'm going to give you an equation in standard form, and we're gonna have to go ahead and graph it. I'm so sorry if I can't speak right now. It is early in the morning, so bear with me. All right, one other thing that we should definitely know, and we're going to practice, is completing the square. So of course, if you are in Algebra 2, usually if this is in pre-calculus, this is something that you should definitely know because you're going to be given equations. They call it in general form, and we're going to have to complete the square to one, identify the conic, and of course, write it in standard form. So let's get started. I'm going to give you a graph here, and we're working on the very first problem on the top. And this is already in standard form, so we have to identify one, what the center is, and what the radius is going to be. And remember, the center was the H comma K. The center in this case is going to be 3, 4. I keep saying in the parentheses, it says X minus 3, but that means it's a translation of 3 units to the right. So the center is just going to be a positive 3. And for the other value, the Y minus 4, it's a translation of 4 units up. So it's going to be a positive 4 for the Y coordinate. And the radius is technically not 4, but the square root of 4. Because if you recall from the standard form, the equation was equal to R squared. So in this case, the 4 was equal to R squared. And if we end up taking the square root, we're going to have 2 equals R. So that is our radius. I'm just going to go ahead and put that value up on top. So how do we graph it? I mean, pretty simple. The center is 3, 4. I'm going to go ahead and graph that point on the graph there. Now, how do we graph the other points for the circle? I mean, there's infinitely many circles or infinitely many points in a circle, but there's, I believe, just 4 points that maybe we should graph every single time. Once we have the center, since we know the radius is 2, let's just move 2 units to the right, 2 units to the left, 2 units up, and 2 units down. So check this out. I'm going to go ahead and do that now. I'm going to graph my points in blue so you can visualize what I'm doing. So 2 units to the right, 2 units to the left, 2 units up from the circle, and then 2 units down from the center. And you're going to try your best to draw an accurate circle there. Looks pretty good, I'd say. Let's do this next one. This is usually one of the easiest types of problems that you can definitely see whenever you're out in Algebra 2 or you're studying pre-calculus. There's nothing that the X is being subtracted or added by. Same thing for the Y. And that's because it can be rewritten just like I have it here. So let's see if you can figure out what the center is here. The center is 0, 0. There's no translation to the right, no translation to the left, nothing going up, nothing going down. And now we have our radius, which remember is the square root of 36. So it's going to be 6. So let's go ahead and graph it now. I have my center at my origin. I know that my point is going up 6 units from the center. I'm just going to go ahead and graph that there. 6 units downward from the center, 6 units to the right, and 6 units to the left. You see that? I graphed the center and then the 4 points that I think are the most important when it comes to a circle here. And now I draw my circle. It's ugly, but when it comes to drawing, if you're not the best artist, that's totally fine. I believe, if you wanted to grab a compass and draw it out, you're more than welcome to, but teachers are more concerned with that you graph your center and then you graph the 4 points to the left, to the right, up and down from the center. And so now let's mention other types of problems that you encounter whenever you are studying these types of circles. So in this case, the first particular problem, they're actually giving you the radius is 5 and the center is -3, 5. And we have to write our equation in standard form. Now, if you recall, the equation is h minus x minus h squared plus y minus k squared equals r squared. Well, luckily for us, we have a good amount of values already. We already have the center as -3, 5, and then we have our radius as 5. So I'm just going to go ahead and plug those in, and you're going to see that we will find the equation of the circle. So I have x minus, now pay close attention to this. I'm going to put a -3 here, and I'm going to be pretty obvious with it as I write my parentheses, plus y minus 5 squared is equal to, and then our radius was 5 squared. Okay. So what do you think happens to this minus in the first parentheses? That minus turns into a plus. And that's what I keep mentioning, that the x minus h or the y minus k can confuse some people. But now this is the first time that we are seeing something like x plus 3. Or the last two problems, it was x minus the whole time. Now, what that means is you can tell the center is the opposite of that +3, so it's going to be a -3. So this is just something to be aware of, that when you see something like this and you see x plus 3 or y plus 5 or y plus 7, whatever it might be, whenever you see it in something plus, that means that our center was moving to the left or down, depending on which variable or which parentheses it is in. Okay, let's go to the next problem. And it's the same thing. Radius is 8 and the center is -1, -6. Let's go ahead and write the equation just so we can be reminded of this. I think it's always important to write not only our work, but I think the equation that we're going to work with, because it helps us register that in our brains and understand that whenever we are encountering some sort of circles or conics, we know which equation that we want to use. So our center was -1, -6, and then our radius was going to be 8. So now all we do is go ahead and plug those values in to our standard form. So x minus -1 plus y minus -6 squared, or yes, equals 8 squared. Now let's go ahead and simplify. In both of the parentheses, there was a minus. So now we can go ahead and write it as x plus 1 squared plus y plus 6 squared is equal to 64. Now I know we're already given the center in the very beginning, but this again is another situation where you can look at the parentheses and say, oh, this is an x plus 1. That means that my circle was translated to the left 1 unit. And because it was a y plus 6, that means that the center was translated 6 units down. And that is, of course, why the center is -1 comma -6. So that plus and the minus inside the parentheses when it comes to translation always just works backwards. So be very, very aware of this whenever you are encountering circles at Algebra 2 or in pre-calculus. And now let's go to the next types of problems. So now it looks like they're going to give us a few scenarios, and we have to go ahead and draw out an equation based on that information that we are given. So let's go to the first one. Write the equation in general form with center 3, 5 and tangent to the x-axis. I know it said general form, but for now, because we haven't really talked about general form, I'm just going to change that, and we're going to write it in standard form. So once again, like I mentioned, let's just go ahead and write the equation for standard form on here. And again, every time you're encountering these types of things, you want to just write out your equation. I think it's great to process what's going on. Now, we know the center is 3, 5, and they say it's tangent to the x-axis. What does that even look like? Let's draw something out just to visualize what's going on. So I have the best x and y axis that I can possibly draw. I have my center somewhere here. There you go. And now it's saying it's tangent to the x-axis. Tangent to the x-axis, that definition is going to be important when you're doing conics. Obviously, it's going to be very, very important when you're doing calculus. But for now, just keep in mind that whenever they're talking about tangent, they're talking that it's touching at one specific value. Like it's just barely touching, in this case, the x-axis. It is tangent. So that means that our circle is going to be just touching the x-axis. And you can visualize right away that the center, because it was 3, 5, we can already tell that the radius, because the distance from the center to the x-axis is just going to be 5 units. And that is, in fact, our radius. So we can go back. And now remember, since our h and our k was 3, 5 respectively, we can go ahead and plug those values into our equation. So we have x minus 3 plus y minus 5 squared equals, and then of course we have the radius squared. And now we can simplify. X minus 3 squared plus y minus 5 squared equals 25. All right. Now the next one, number 12, a different scenario that you can encounter, but not as difficult. If anything, this is probably going to be the easiest one of the three, because they want us to say, or they are mentioning that they want us to find the equation of the circle, and it has the center 2, -3 and radius 6. Not as difficult as we might think. Again, whoops, I'm using a highlighter here. We have x minus h squared plus y minus k squared is equal to r squared. Well, it looks like we know our center and we know our radius. So I'm just going to go ahead and plug all those values in. 2 squared plus y minus, check this out, the k value is -3, so I'm just going to be very obvious with those, or in with the -3 there, and as I write my parentheses, equals 6 squared. Okay, let's go ahead and simplify whatever we need to. X minus 2 squared plus y plus 3 squared equals 36. That's our equation. This is the standard form for a circle with the center 2, -3 and radius 6. If you're ready, let's go to the next problem. That's going to be in 13. Now, this is the hardest, possibly I would say the hardest one out of the three. They want us to find the equation of the circle. We have the center 2, -3. Once again, we know that this is our h, and we know that that is our k. But now we don't know the radius. So before I even plug anything in, let's go ahead and write the equation. Oops. My R looked a little janky there. All right, so h is 2, k is -3. Let's go ahead and plug that in first. X minus looks like 2 plus y minus, and then of course I'm going to be very, very obvious with my parentheses there, equals r squared. We don't know what the r is. That's the fun part of this whole thing. We need to figure it out. But they give us a clue. They tell us that it crosses through the point 4, -2. That's that point that they mentioned at the very end. So now we know that when x is -4, y is 2. So we can go ahead and create an example equation, is like I like to call it, because when x is -4, y is +2, and we have those variables in the equation there on the bottom, so we can go ahead and plug those values in. So let's do that now. So I have -4 minus 2 plus 2 minus -3. I'll fix all that in a second. Squared equals r squared. Again, we don't know what r squared is, but we're about to find out. -4 minus 2 is -6 squared plus, and then be very careful with this, 2 minus -3. That's the same thing as 2 plus 3. So that's going to be 5 squared equals r squared. Okay, so now we have 36 plus 25 equals r squared. And 26 plus 25 looks like it's 61 equals r squared. Now this is interesting. I want to briefly talk about this. R squared is equal to 61. That means that r is some interesting value, square root of 61. We're not even going to simplify. We're not going to use our calculator to find out what that is in decimal form. Why? Because we don't need necessarily the r value. All we care about is the r squared, because we're just going to use that to plug that into our equation. So on the very bottom, now we know that this is x minus 2 squared plus y plus 3 squared. I already just simplified that minus -3 equals, and now, as I mentioned, we don't need necessarily the r. We already know r squared is just 61. And we can just write our value like that. Hopefully that made sense. Again, this is probably one of the hardest problems whenever you are encountering circles. So if you have questions about this, comment below, and I'll try to make possibly another video or just answer your question that you might have. Now we're going to head to the last problem, or the last two problems that we have, and that's going to be general form. If you recall, in the previous page, I said, okay, we're not going to talk about general form just yet because we haven't really seen it. But now this is what general form looks like. You have these equations in terms of x squares and x's and y squares and y's, and you have these constants. And the idea is that you want this entire value to be equal to 0 for now, and you want to convert this into standard form. So one thing that we are going to have to be very aware of, one of the skills that we're going to have to know, is completing the square. So if you don't know completing the square yet, maybe that's something that I'll have to make another video about, but completing the square is essential to knowing whenever you have problems like this, converting general form to standard form. So how do we do that? The very first thing I would actually suggest is to combine all the x's together. Put them right next to each other. I have an x squared plus 4x, and I have a y squared minus 32y, and I'm just going to go ahead and let's move the 256 to the other side and make that negative 256. Okay. And I kept saying put the x's next to each other, not necessarily combine them because the x squared and the x can't combine. Same thing with the y squared and the y. Just put them next to each other, because now what we're going to do is we're going to work one variable at a time. Let's just work with the x's, and we're going to complete the square. So if you recall, completing the square is you take the b value, which in this case is r4. You're going to have to divide it by 2 and square it. So 4 divided by 2 is 2, squared is 4. So that is the new value that we're going to add. So we're going to have plus 4 plus y squared minus 32y. And guess what? You're also going to have to complete the square for that one. So you're going to take the negative 32. Maybe I'll put my work here on the far right. Negative 32 divided by 2 and square it. And that's going to become negative 16 and then negative 16 squared. And that's going to be 256. I wouldn't say it's a coincidence that we have 256 and 256 now that we're going to introduce that, but perhaps there's a reason for that. So now what we're going to do, we're going to introduce that 256. And if you notice, this equation is now a little different from the equation on top. Why? Because now we have a 4 introduced and we just introduced a 256. So what we have to do is algebraically, we have to balance it out. We have the negative 256 originally, but because we introduced a 4 and a 256 on the other side, we have to make sure we also introduce that to the right. Okay. And this is the cool part. Whenever you complete the square, these values, so if we focus with the x, that's just going to turn into x plus 2 squared plus y minus 16 squared. Again, if you feel like I need to make a video about completing the square, let me know in the comments below. But at this point, if we're doing circles and we're doing conics, completing the square should be a very, very strong math survival skill that we have perfected. But if not, maybe that's something that you're going to have to revisit. And if you need me to do it, go ahead and comment below and I will try to do what I can. So x plus 2 squared plus y minus 16 squared equals, and now on the right side, we have negative 256 plus 4 plus 256. Luckily for me, I don't have to do much work in my head or use a calculator because the 256 cancels out and we are left with a 4. Nice. This is standard form now. Now, they're not gonna, or they didn't ask us for the center or the radius of the circle, but we can technically go ahead and find that now. Do you know what the center is? You have an x plus 2 in the parentheses and a y minus 6. If you said negative 2 comma 16, you are correct. If you said anything else, we should probably continue practicing, and that's okay. Nothing wrong with that. So now the radius, it's not 4. I think naturally a lot of people will want to say that, but we have to make sure to take the square root of that, and that's going to be square root of 4, which is going to be 2. Center and our radius. Great. If you're ready, we are going to do the last problem. Another completing the square. And as I mentioned, completing the square is a very, very important math survival skill to know, because it gets more difficult in a situation like this, and not just circles, but whenever you are doing parabolas, whenever you're doing ellipses and you're doing hyperbolas, things get messy sometimes. So completing the square is just essential. Now, you're probably going to see some of my videos, but I just don't like completing the square when it comes to solving quadratics, but I still think it's essential to know when it comes to conics, obviously, and there's going to be other scenarios where completing the square is helpful. Now, same thing here. I'm going to group my x's, and I'm going to group my y's, and I'm going to move the 24 to the other side. So that's 24 there. Now, what's the difference between this problem and the other problem? These equations now have a 3 in front of the x squared. So the a values for their respective variables are no longer 1. So the very first thing before we even complete the square, and again, this is something that we learn when we explore this method, is you want to factor out, for example, let's just work with the x's. Let's factor out a 3. You want to factor out that entire value, because inside the parentheses, you want a solid 1 as your a value inside that parentheses. So you don't want anything in front of the x squared, so you want to go ahead and just remove that by factoring out a 3. Same thing's going to happen for the y. If I factor out a 3 there, I believe that's going to be y squared minus 16y. Okay, and nothing so far on the right side. And now we're going to go ahead and complete the square. This is where we take the b value, which is 6, divided by 2, and square it. So 6 divided by 2 is 3. Squaring that is 9. And I'm just going to go ahead and show you what we're going to do for the y value as well. Negative 16 divided by 2 squared. Looks like that's going to be negative 8 squared, which is 64. And so now we have 3 times x squared plus 6x plus the 9 that we're introducing, plus 3 times y squared minus 16y plus the 64 equals 24. And if you recall what we did last time, because we introduced new variables or new values on the left side, we have to balance that out and do the same thing on the right. But this is a little different because we're not just going to, introduce a 9 on the other side, and we're not just going to introduce a 64. We have to do something a little different because the 9 and the 64 are inside the parentheses. So technically, we need to introduce a 3 times 9, which is 27. So that's a 27 that I introduced on that side. And then the same thing for the other value. 3 times 64. That looks like it's 160, 190, 180, 192. Sometimes I'm talking to myself in my head. I'm talking out loud, but I'm trying to just solve these basic multiplications. I know. I am the one tutoring you on how to write these general form into standard form. Okay, so now let's go ahead and simplify the left and simplify the right. On the left side, we have 3 still times, and then x plus 3 squared plus 3 times y minus 8 squared equals, and now we have to combine all those values together. That is 243. Now you might think, okay, we're done. My center is -3 and the center is going to be 8. And then the radius is going to be whatever the square root of 243 is. But again, things get a little tricky here and a little messy. Why? Because you'll notice that there's still 3's outside the parentheses. And we don't want that because the general form or the standard form for a circle did not have that. It didn't have anything outside the parentheses. So what we have to do is we have to divide everything by 3. And that will simplify into this particular value. So for the first fraction, or for the first parentheses as well, the 3's cancel out. So we're left with x plus 3 plus y minus 8 squared equals, and now all we have to do is divide the 243 by 3, and that gives me 81. This is the equation of the circle that was in general form and now turned into standard form. And as you can tell here, our center is -3, 8. I put -3 there for a reason because the first parentheses has an x plus 3, and that was not what the standard form for the circle was. So we always have to adjust it. And the radius is going to be the square root of 81, so it's going to be 9. Great. This is some of the problems that you can encounter whenever you are studying circles. So this is something to be well versed on and well aware of. All right. So if you have any questions, please feel free to comment below. Follow me on Instagram, follow me on TikTok, subscribe to this channel so I can continue putting math content out for you. All right. I wish you the best of luck out there. I am here for you if you need me. But until then, happy trails.